Hello friend, welcome to Marine Engineering Hub. This is your narrator Ravi Gupta. Today I'm going to talk about Impress Current Cathodic Protection ICCP in short. This is a very important topic which is mainly asked in MEO class 4 and MEO class 2 exam also. In today's topic I will tell you what is ICCP. After that we will understand what is galvanic corrosion, electrochemical series, and after that I will go and tell you how this galvanic corrosion and electrochemical series are related to ICCP. And then I will tell you the basic component and main component of ICCP, and then I will tell you how it works and how why it is provided. After that, we'll see the advantages and disadvantages of ICCP, and through this diagram, I will explain how it is implemented on board ship. So please remain tuned till last. I guarantee you all the doubt regarding ICCP will be clear today. So let's begin the video of the ICCP. So ICCP stand for Impress Current Cathodic Protection. So it is basically a system which is installed on ship to protect the hull corrosion. In modern shipping industry, almost all type of ship which is now constructed use ICCP system. Why? Because it eliminates the installation of sacrificial anode on every ship which was earlier used to replace 5 to 7.5 year of dry dock period. So basically what happened, what I mean to say, when ICCP system was not there in earlier ship, at that time we used to fit a sacrificial anode which we need to replace after a period of 5 to 7.5 year in a dry dock interval. And though the sacrificial anode was provided, there was still a substantial amount of hull corrosion occurred. So to prevent the hull corrosion, basically this ICCP system was provided. Now to first understand the ICCP, we should understand electrochemical series and galvanic corrosion. So first we'll see galvanic corrosion. So what is galvanic corrosion? So what happened when two dissimilar metal, okay, are in contact with each other in a presence of corrosive medium? The more active metal act as an anode and undergoes corrosion, and less active metal act as a cathode and is protected by anode. So what is happening here? The mistake I have done, it will be dissimilar. Okay. So when two dissimilar metal are in contact, so basically what happened, if they are two metal and one metal which is active will act as an anode and which is less active will act as a cathode. And to protect the cathode, the anode will erode itself, means will consume itself by forming a coating on a cathode. So therefore, this sometimes are called sacrificial anode because it is sacrificing itself to protect the cathode. So this cathode anode decision is been taken depending upon metal with having high oxidation potential are more reactive. So as I am telling you now, means more active metal, this activeness of the metal is determined by electrochemical series, means metal which is having a high oxidation potential are more active compared to having less oxidation potential. So high oxidation potential means having high tendency to form anode, okay, compared to the other one. So suppose if there are two metals such as copper and zinc, and in this case what will happen, the zinc will form anode and copper will form cathode. So what we can say that this zinc is more active than copper. So how it is decided that zinc is more active than copper? It is decided on the oxidation potential. Zinc's oxidation potential is much higher than the copper, and hence zinc will react first compared to the cathode, compared to the copper. If lead and nickel is taken, in that case nickel will be act as anode and lead will act as cathode because nickel is more active compared to the lead. Same way, if iron and zinc is taken, then zinc is act as anode and iron will act as cathode. So all these thing, this activeness is decided on the electrochemical series. So what is happening, this is a electrochemical series. As you can see here, I'll show you first. As you can see here, that the zinc, okay, here is the zinc and here is the iron. So zinc is acting as a anode and iron is acting as a cathode. So if we come here in this form, so as you can see here, zinc is having an potential of 0.76 compared to the iron having 0.44. Hence, zinc is more active compared to the iron. In the same way, if I have told you copper and zinc, if you see copper is here, okay, and zinc is here. So for that reason, when these two are placed in this way, depending upon the electrochemical series, the things are decided. Now, as you can see here, okay, so this is a simple galvanic cell having one copper and one zinc rod, which has been connected through a via voltmeter. Now what happened, copper will undergoes reduction and zinc will undergoes oxidation. So having high oxidation potential, zinc will act as anode and copper will act as cathode. Okay, and the electron will flow from negative to positive and current will flow from positive to negative, and hence we will see a deflection. These both are dipped in an electrolyte which are connected to this salt bridge. Okay, now, so basically what is happening, what I want to tell you, this basically what is happening in a ship, that suppose the ship propeller is made up of screw or bronze, and the salt is acting as a salt water, means seawater is acting as an electrolyte, and the ship is made up of stainless steel. So there are two different metal, stainless steel and screw bronze. So these two are different metal which are connected by a common electrolyte which is seawater, and hence a galvanic reaction take place. How this galvanic reaction take place? As you can see, compared to the bronze, the stainless steel is having a high oxidation potential compared to the bronze, and hence the stainless steel will act as an anode, and this screw bronze will act as a cathode, and therefore hull corrosion will occur. So as you can see, this this is stainless steel, this is the bronze. Now this is acting as a anode, this is acting as a cathode, and now what is happening, the current is moving from negative to positive, sorry, the electron is moving from negative to positive and the current is moving from positive to negative. So this way the corrosion is started. Due to uneven wear and patches of the paint, different zones are created on and in the ship hull, which will have a different in metallic structure, which ultimately led to the galvanic corrosion where the seawater acting as an electrolyte. Not only in the aft section where there is a vast difference because of propeller having different material and hull is having different material. At the aft, the corrosion is very much at the higher rate if there is no any preventive anode is provided. But in the front and in different part of the ship, because of the different form of corrosion, means erosion, also water erosion and different wave erosion, the paint at some point get eroded, and therefore the different zone are created in a metal form, and hence again small patch form galvanic corrosion occur. So moreover, on the aft of the ship, galvanic corrosion chances are exceeded because of the difference in materials such as propeller and ship hull, as I have told you. So I want to tell you one more time that what I am telling in first paragraph is the in place different patch type galvanic corrosion which is occurring at different part of the ship because of wearing of the paint, leading to a different galvanic corrosion zone occurring. And second is the zone which occurring at the aft of the ship, which is very much common and very easily can be found. Propeller of the ship is made up of magnesium aluminum bronze as compared to the alloy steel of ship hull. Therefore, ship acting as a cathode undergoes galvanic corrosion. In order to prevent galvanic corrosion, ICCP system is implemented on ship. So I hope you understand how the galvanic corrosion occur in ship. So till now I have told you how a galvanic corrosion occur and what is galvanic corrosion, and after that you can now understand how it is occurring. Now let's see and how an ICCP work. Basically, the ICCP consists of three components: reference electrode, main control panel, and impressed cathode. So basically, it consists of three things: reference electrode, MCP, and impressed cathode. As we all know, due to electrochemical reaction, a current flow between an anode and cathode. So as I have told you, depending upon the thing, the current flow direction will be opposite of the electron flowing direction, and this current will flow if there is a galvanic corrosion occur. So this current flowing between the two different metal undergoing galvanic corrosion, if we can measure this current and if we can apply a current higher than this in a opposite direction, in that case we can prevent the corrosion. Okay, one more time I will tell you in later on. With the help of a reference electrode, the electric current is measured and it is sent to the main control panel, where the process current is sent to the impressed cathode, which prevent the electrochemical reaction and prevent the galvanic corrosion. This process current is slightly more than the measured current from the reference cell in order to overcome the electrochemical galvanic reaction. So what is happening? Basically, this is a reference cell. This reference cell will measure the current which is which will flow if a galvanic corrosion occur between ship's hull and propeller. Suppose if we measure that, okay, 0.5 megavolt current is flowing between ship hull and propeller if a galvanic corrosion occur. That is been measured by this reference cell and is sent to a power source. This power source will measure this current and will supply a current higher than that, suppose 0.7 megavolt, to the anode to in a positive direction to prevent corrosion. So what is happening? Suppose this is a cathode, means this is a propeller, okay, and this is the anode, which is a ship hull, which is undergoing a corrosion to prevent the cathode. So the main aim of ICCP is to prevent this anode. So in order to prevent this anode, what we are doing, we are using an impress anode, which is called impress anode. This impress anode, through this impress anode, we are supplying an DC current, which is slightly imposing more current in opposite direction, which is being generated between these two. So what is happening? Suppose between this anode and cathode, a current of 0.5 megavolt is generated, which is flowing from anode to the cathode. Okay, from anode to the cathode. Now, if we can supply a current such that which is provided in opposite direction, then this will act as a cathode. Okay, this will act as a cathode. Okay, so this is done by this impress anode. Through this DC panel, main control panel, the DC current is provided to this anode through this anode. Okay, to through this main panel we are supplying DC current such that this anode will act as a cathode and will prevent the hull corrosion. Okay, so what we are doing, basically in a simple way, if we say, we are reversing the electrochemical galvanic corrosion reaction. We are preventing the corrosion to occur so that by imposing a slightly more current in a reverse direction. By doing so, by imposing a slightly more current in a reverse direction, we are making the ship hull as a cathode. Instead of anode, it is converted into a cathode, and hence the hull corrosion is been prevented. Okay, now this DC current is been provided by an AC DC rectifier means from the generator the current is processed through a rectifier unit and converted into DC, and the process current means the current which need to be required to be sent is decided by the main control panel, and that amount of current is been sent to the impress anode. This impress anode is basically insoluble type of anode which need to be fitted only once, as it is insoluble and basically made up of platinum or graphite, and once installed it will continue to be used for a period of up to 20 years. Okay, and same thing I've written here. In normal scenario this will act as a sacrificial anode. If there is no impressed anode is there, this will be acting as an anode, will get corroded and will be preventing the corrosion of propeller. But due to impressed anode, this anode is converted into cathode by passing DC current and reversing the electrochemical reaction. Okay, now, so as I've told you, the ICCP consists of three components: reference electrode, main control panel, impress anode will be there. Okay, now this impress anode, basically what happened, this impress anode basically is getting power from this main supply panel. Okay, so the process current which is sent to the impress anode is DC current, which is rectified by a rectifier. This AC current produced by the generator is converted into DC through rectifier, and this amount is controlled by main control panel, and the process DC current is sent to prevent galvanic corrosion. So it's very clear. Impress anode. These anodes are an inert or insoluble anode such as platinum, graphite, titanium, which take part in electrochemical reaction but never get eroded. Very clear. Now let's see the advantages of a ICCP system. It is a maintenance free system. Once installed, we don't require any further maintenance, and it can continue up to a period of 20 years. It eliminates the requirement of sacrificial anode to be fitted on ship. The impress anode which is fitted are not welded to the ship's hulls, hence welding is no more required for fitting an anode. Why it is tell? Because for installation of sacrificial anode we need to weld do a welding on ship. Okay. Disadvantage of ICCP system: installation cost is very high, additional monitoring and maintenance is increased. Is basically the main advantages of the ICCP is very much more compared to the disadvantages. Now this is a simple representation. So basically what is happening, at different point we are fitting the reference electrode, and this reference electrode is measuring the undergoing galvanic corrosion which will occur, and the current which is required to prevent that galvanic corrosion is been measured by this reference electrode, and this is being sent to the power supply unit or main control panel, and after that the current in the reverse direction and having slightly more power is sent through the impress anode, and the corrosion is prevented by making the ship hull acting as a cathode. So this is how an ICCP system works. At a last, if you have a confusion, I am just telling in a synopsis what is happening. So basically, suppose this is a propeller which is made of bronze. This is the ship hull metal which is made of steel. Now, in normal scenario, what will happen? The steel will be eroded onto the propeller because the alloy steel is more reactive compared to the bronze, and hence it will undergo corrosion. While undergoing corrosion, it will act as an anode and it will act as a cathode. To prevent the corrosion of hull, we are using a system called impressed cathodic ICCP system. In this system, we are using an anode which is insoluble in nature and which is providing a current slightly more than which is required, which will be generated when this reaction is taking place of anode and cathode. And by impressing this current, we are making this anode into the conversion into the cathode, because now this is acting as an anode and this is acting as a cathode and cathode. Now this anode as getting converted into a cathode, therefore it is being protected by this anode as the current is provided in a reverse direction, which is preventing the corrosion. So this is how the system is work. If you have got still any doubt, please do comment below. I will try to explain. And if you like the video, please do subscribe and please do share with your friend. Have a good day, friend.